Welcome to the Cow Corporation's series of videos about software engineering. The topic of this video is the sort class used by map collections. Before proceeding, make sure that you have already watched these other videos first. When the programmer types this map literal, it does not matter what order he uses for typing these items. What does matter is the map's sort class, which is the standard less in this example. If the programmer had omitted the sort class, then it would have defaulted to this standard less sort class. The sort class is what determines the actual ordering of items that STL uses in its internal representation. The sort class orders items by their keys. When iterators use forward and backward iteration operations to iterate over the items, that iteration follows the sort class's ordering, ignoring the order that you see here in the literal. A map is not allowed to have two items with the same key. STL uses the sort class template parameter to detect when that is attempted. It detects key equality as an inability to order the keys either way. STL's internal representation of a map will divide the space of all keys into segments. In this example, STL internally manages key segments from -infinity up through A, and from A through I, from I through O, from O through U, and from U up through infinity. In each case, that key segment has an inclusive start and an exclusive end. These key segments are directed like I to O instead of O to I because of the sort class template parameter. Now, let's insert another item into the map, an item whose key is E. STL will replace the A to I key segment with two new key segments, A to E and E to I. Each of the map's items can be thought of as being a representative of a key segment. You can query information about this internal representation by passing any potential key to this equal range function. First, let's consider a case like this I, which is a key that is being used by one of the map's items. Because I is some item's key, equal range will return a pair having two different values. You can discover that I is currently representing the I to O key segment by inspecting those two values returned by equal range. There are two shortcuts for accessing that information. This lower bound function is a shortcut for accessing the start of a key segment. This upper bound function is a shortcut for accessing the end of a key segment. In the case of the last key segment, its ending, being at infinity, is represented by the special null iterator that's at the end of any collection class in STL, including map collection classes. Next, let's consider a case like this J, which is not a key used by any of the map's items. Because J is not any item's key, equal range will return a pair that repeats the same value twice. That value will be O, because O is the first key after J, which does get used by some item. In other words, O is the end of the key segment which contains J. What about the storage of the data itself? Internally, the collection's data is stored as a binary tree, where the left child is smaller, according to the sort class, than a node, and the right child is larger than the node. Because of this choice of representation, sorted collection classes, like map, cannot provide any appending type of operations, such as the pushback function that we saw with vectors. We can't just append some random new item to the end of this map collection, because doing that would usually violate the sort class's ordering. And because of this choice of representation, when you access any map item via an iterator, you receive a constant reference. That prevents you from changing its value in a way that might violate sort class ordering.